Good morning, everyone. Welcome to BlinkOn 13, and thanks so much for joining. I'm PJ. I'm a product manager on the web platform team, and I'll be emceeing today. If closed captioning would be helpful for you, you can enable it in the bottom toolbar of this video chat app. Just look for the Turn On Captions button. I want to start by taking a moment to acknowledge the global challenge that's represented by this pandemic, both the direct and tragic harm that it's inflicting on our communities, as well as the indirect harms, such as making it harder for all of us to connect with each other in person at events, just like this one. This is the very first virtual conference for BlinkOn. I know that it can be really hard to sustain attention without moving around, so I encourage everyone to take breaks, stand up, stretch it out. Please make sure that you're getting a little bit of movement in there during the day. But I would also like to urge you to be as present as you can for the event. At a virtual event, it's more tempting to step away, focus more on day-to-day work, emails, etc. But this is a really rare opportunity when so many of the different Chromium developers have cleared their schedules to participate. You're only going to be able to get a lot of this conference if you're able to set aside time to participate and consider joining the Slack rooms and breakout sessions to get the most out of the event. A couple of other small housekeeping items. BlinkOn 13 has a code of conduct, so please do have a look at the BlinkOn 13 FAQ for details and contact information to report a COC issue. Secondly, hopefully I don't have to tell you where the coffee, snacks, or bathrooms are. I'm pretty sure you know where those help you do. And finally, since this is our first ever virtual conference, your feedback this time is more important than ever. I think it's reasonable to expect that there will be other future virtual events as well. And the post-event survey is going to be what's going to help us to understand how we can make virtual events more engaging, more fun, and more valuable to everyone who participates. I'm now going to pass this over to the keynote speakers, Danyao and Yoav, to introduce themselves.
Good afternoon and good evening, everyone, depending on where on this round globe you currently are. I'm Yoav Weiss.
And I'm Danyao Wang. We're excited to welcome everyone to this virtual edition of BlinkOn. This year hasn't been easy for face-to-face gatherings like PJ just mentioned, and we did have to cancel BlinkOn 12 earlier this year. But it's really great to see so many people able to come together virtually to share knowledge, work together, and dream about what's next. First of all, a fun fact. Any guess what this number stands for? So this is actually the amount of Arctic ice we are able to spare as a result of not flying everyone into Kirkland, where BlinkOn 13 was originally planned to happen. So silver lining for the pandemic year. So please pat yourself on the back for doing something good for the environment. On a more serious note, though, this year we have 407 attendees representing 33 companies and individual contributors coming together to BlinkOn. One thing I love about being in Chromium is this community. It's really cool to see so many people and groups with different priorities coming together and finding solutions that not only meet their individual agendas, but also advance the common goal of improving the web. As someone who is still relatively new to Chromium and Blink, I feel extremely lucky to be part of the collaboration of this scale. What about you, Yoav?
Same for me. The reason I've been attending most BlinkOn since 2014, way before I joined Google, is that it's always an amazing gathering of an incredible community, the Chromium community. Just last week, we had our first instance of the full-fledged Chromium University rather than the Google internal Chrome University event that we used to run. We had 643 attendees from 60 different organizations, including lots of independent folks. So that's great. I also took a peek at this year's Chromium commit data, compared it to previous years, and found a bunch of interesting points. So if we look at non-Google contributors to Chromium, we can see that 2018 was somewhat of a low point, but that we see steady increase in non-Google contributors since. And that is not because Google is somehow investing less. There are actually almost 90 more Google contributors this year compared to last year. But non-Google contributors are growing at a higher rate. Other companies are increasing their investment in Chromium and the web platform, and that is awesome to see. If we look at the distribution of who those contributors are, we can see that the percentage of independent contributors is up from 17% to around 20% of the overall non-Google contributors. And similarly, Microsoft's contribution are up from 32 to 35%, and Intel and Igalia are also up. Looking at commit volume, we can see that Igalia is the #1 non-Google committer, but Microsoft are closing that gap quickly and ramping up. Speaking of Microsoft's contribution, and we've seen a lot of improvements across the board. It's very hard to call out all the amazing things that they did on a single slide, but I'll give it a try. We saw a ton of accessibility improvements, from stability to low contrast mode improvements, battery life improvements through improved resource loading, better forms by revamping the existing forms and by working on making them stylable, improved media playback and hardware decoding on Windows, out-of-process canvas rendering for better performance, improved font legibility on Windows, grid NG implementation to support the CSS grid in our new layout NG stack, as well as out-of-flow segmentation, scrolling improvements, including work on the scroll animations API, editing improvements, including work on the virtual keyboard API, WebXR work with OpenXR backend and hybrid GPU support, work on ES modules to support CSS, JSON, and HTML modules, work on the storage access API on the privacy front, and a ton of other improvements to our release quality and security. And I've personally have been constantly amazed by site breakage issues that Microsoft folks keep finding and reporting. I wasn't excited about sites breaking related to my changes, but I was super happy that they found out about this relatively early, and it's just amazing work, amazing to see that happening. Similarly, from Igalia, we have a huge list of achievements. They made a ton of CSS improvements, including marker, pseudo elements, flow relative shorthands, and CSS grid improvements and maintenance. They shipped the JavaScript private methods, protocol handler improvements, and did a bunch of improvements to our layering through the Onion Soup projects, to our accessibility, as well as Linux support. And one reason I'm particularly excited about Igalia's contributions is that, in a way, they represent an industry investment in Chromium and the web platform. They provide a way for businesses that operate on the web to say, there's a part of the platform that is not good enough for our business, but we're actively investing to make it better. That improves the platform for everyone. One recent example of that is their open prioritization experiments, where they fund various web platform feature implementations by getting the broader community to chip in and pay for that work to happen. Intel, we're heavily involved in media capture, and in particular in pen, tilde, and zoom support, in web codecs and video acceleration. They've been a long-time contributor to the Fugu project in order to increase the platform's capabilities. And they also contributed to PWAs and were involved in the foldable screen and dual screen APIs. And finally, Samsung have been investing in WebXR as well as foldable screens, and bringing the web to those new and exciting form factors, as well as investing in progressive web apps and payment requests. On the Chrome team's front, Chrome infrastructure team is investing to improve tooling for community contributors, and Goma is now available for faster build to external contributors. It's not perfect yet, but it's a great first step, and we're hoping it will get better. And on the API owner front, we now have a well-defined process to nominate API owners, similar to the way folks can nominate committers. That's a new process we added this year, and we already have one new API owner that was nominated through this process, Rigo from Igalia, and he done a great job as an API owner since.
That's an amazing summary of some of the community contribution. Thank you, Yoav. I do want to talk a little bit about why we're still here. After all, this is the 13th BlinkOn, and the web has just celebrated its 30th birthday last year. So for browser folks like us, what is there left to do? To me, the answer is that the web is evolving. The web used to be synonymous to what is accessible through browsers. But these days, users can access the web through many different form factors, including hybrid apps, XR, and more recently, devices with more than one screen or foldable screens. These new form factors enable new possibilities for the user to experience the web beyond the traditional rectangle and the back and forward buttons. Blink, as an implementation of the web platform, must evolve with the ecosystem and meet users' increasing demand for convenience and richer experience. The new form factors are bringing new user needs. Meeting these new user needs require addressing all three dimensions of security, privacy, capability, and user experience. This creates interesting and challenging engineering problems for all of us to solve, as it is not always possible to solve all three requirements at once. In addition, as a platform, more often than not, we meet user needs by empowering web developers. This gives us scale, but as a trade-off, we don't have as much visibility into the use cases themselves. So just like a commercial jet pilot who cannot rely as much on their site as that pilot of a small seaplane, we have to use instruments. This is why we invest in metrics such as the Core Web Vitals, feedback channels such as MDN survey, and test automation such as web platform test, and better debugging and diagnostic tools across the board. Next, I'd like to just highlight a few accomplishments that we have achieved this year over in these fronts. Security is one of the foundational pillars of Blink. A big update this year is a cross-origin isolated context. After the detection of Spectre in 2017, powerful features such as shared array buffers were disabled in Android to guard against similar speculative timing attacks. With this new launch, pages can opt into a cross-origin isolated states and be able to use shared array buffer and some other powerful features such as memory instrumentation and JS profiling again. Another significant change is a recent addition by Microsoft. By default, pages that are opened with target equals blank can no longer control their opener and vice versa. This improves both performance and security and aligns Blink's behavior with other engines. We continue to improve the SecFetch headers to give servers more control over security decisions. SecFetch Desk is the latest addition. It can help ensure contents sensitive information from finding itself in context it's not supposed to be in. We were also able to auto-upgrade mixed content types because more HTTPS is always great. Separately, privacy is top of mind for users, developers, and web platform developers these days. The Privacy Sandbox is a big effort to reimagine the web without third-party cookies, but without breaking the ecosystem and the funding models along the way. We're doing this by providing alternative APIs to important use cases that are enabled by third-party cookies today. As part of this effort, we shipped same-site cookies by default. This requires explicitly opting to delegate cookies to third-party contexts. This tightens up the default and ensures that cross-site cookies are only used intentionally. Fingerprinting is another major privacy threat on the web. User agent string is an easy, high entropy vector. We're in the process of rolling out user agent client hints, an alternative mechanism to the traditional user agent string. This is part of a larger effort to significantly reduce the fingerprinting surface on the web over time. And we have many more proposals under development. One interesting example I'd like to call out is the Storage Access API contributed by Microsoft. Although Chrome is not currently planning to ship this, the Blink API owners were supportive of landing a Chromium implementation to enable Edge and other Chromium-based browsers to support it if they wish. The fact that the different browsers built on top of Chromium can and do have different opinions on many things is a feature of our project. We believe that the user's interests are best served when different browsers can experiment with different choices when there's not yet a clear consensus.
Moving on to user experience improvements, which are critical to make sure our users stick around on the web. We shipped refreshed form controls, a community effort largely led by Microsoft folks, who also did a ton of work to enable stylable form controls, which will enable developers to style the browser's controls rather than implement their own. Because when developers implement their own controls, that both have developer costs as well as user costs to enable that. On the media front, we have request a video frame callback, which allows web apps to know which video frame was presented to the user and enables them to sync other operations with that. AVIF is a new and exciting image format based on AV1, the AV1 video codec, that enables around 50% size reduction compared to the previous generation of image formats, which is amazing and can improve performance for all of our users. Web Codecs is a low-level API that gives developers access to media codecs, enabling web apps to run their own media encoding or decoding pipelines without re-implementing those browser primitives in JavaScript or WebAssembly. We also saw a ton of CSS improvements. On the user experience front, we saw marker pseudo elements that enable fancier lists, image orientation that enables the image data to control its own orientation, and page orientation for page media. On the performance front, we had content visibility, which enables the browser to skip layout on invisible parts of the page, which can be a huge performance boost. We saw contain intrinsic size, which enables developers to specify placeholder size, reducing layout shifts. And on the improved developer tools front, we saw revert, which enables developers to roll back cascaded values. I also had the personal pleasure of reverting that particular CL and then reverting the revert, resulting in a revert of revert of revert CL commit message, which was a lot of fun. We have flow relative logical properties, which make it easier to write internationalized content. And there's work underway to support CSS modules, which will enable modern CSS loading patterns. One particular prototype I'm specifically excited about is the work on container queries, a feature that the developer community has asked for a long time. And they will enable responsive CSS workflows when working on components. Similarly, for JavaScript, there are a lot of improvements. On the capabilities front, we have shared array buffers on Android enabled through the isolated contexts work, and which will enable fast communication between different threads and a lot of applications that aren't possible in the web without them. Similarly, for WebAssembly SIMD, that enables the platform to make use of hardware parallel execution capabilities, and it's currently in origin trial. And weak references enable to store JavaScript objects, for example, in caches, but still allowing them to be garbage collected. And on the developer front, we have top-level await, which is a long-awaited feature, enabling developers to await on promises outside of async functions, JavaScript private methods for easier encapsulation, and many other exciting additions. One of the key ways of ensuring web experiences are getting faster and staying faster is providing user experience-oriented metrics that developers can easily keep track of. That is what the Core Web Vital program is all about. It defines a collection of such metrics and thresholds across the different dimensions of user experience, visual rendering, responsiveness, and user annoyance. The metrics are surfaced as RUM APIs, are also surfaced in Crux, which is Chrome's user experience report, and provide aggregated, which provides aggregated RUM metrics as well as exposed in Lighthouse. The program was launched this year, but we already see it making a huge difference. One anecdote here from Andy Davies, web performance consultant, shows that customers that started paying attention to the metrics were able to turn things around and double the amount of their users having good experiences while reducing the ones with bad experiences by a factor of 4 within a couple of months. Chrome is also using those metrics to provide signals to the users about links they may click on, indicating if they are considered fast or not, enabling the user to make an informed decision before navigating. And in order for developers to measure their users' experience, there are a bunch of RUM API improvements that we worked on. Buffered flags for long tasks enable developers to measure long tasks that happen before their analytics scripts were loaded, giving them better visibility into long tasks, as well as relieving pressure to load the analytics scripts early, reducing the risk of the analytics scripts becoming a performance blocker themselves. We have the event timing API, which enables web developers to measure event latency and responsiveness beyond just the initial input. Layout instability shifted elements helps developers by providing them information about specific DOM elements that shifted and helping them find the source of the layout shift. And performance.measureMemory estimates memory usage of web pages in isolated contexts in order to catch memory regressions. And it's currently an origin trial. Beyond just metrics to enable measuring fast and responsive experiences, we also shipped a bunch of tools and primitives in this area to enable developers to create such experiences. Is input pending is amazing work from Facebook that enables developers to only yield JavaScript tasks when user input is present, so that on the one hand, they can respond to user input as fast as possible, but without yielding unnecessarily. We have compression streams that expose the platform's compression primitives to developers, enabling them to compress text without re-implementing zlib or gzip. Transferable streams enable transfer of streams to workers so that we could easily offload work from the main thread and onto workers or other contexts. And origin isolation enables the document to opt into being origin isolated, which enables the browser then to give the document its own process when it's possible. And a bunch of other improvements are coming soon. There are exciting experiments for web bundles and sub-resources. Web bundles provide a new approach to load a large number of resources efficiently, and I'm particularly excited about the implications of that. Portals enable seamless transitions across navigations, which is a huge change, but one that can fundamentally improve the user experience and navigation on the web, which is pretty fundamental. Post-task API provides developers with scheduling primitives that align with the platform's own schedulers. Quick Transport is a new API for low latency bidirectional client-server messaging. It's the next generation of WebSockets, I like to think of it. And fetch upload streaming allows pages to be able to upload data in a streaming way, which is super important when uploading large resources. One particular optimization I'd like to call out is the BF cache, a back-forward cache, which enables instant back and forward navigations. We shipped the cross-site variants for that in Chrome 86, and the same site one is planned to ship soon, along with other improvements that will capture more scenarios.
That is an impressive list. On the capabilities front, We heard from developers that they want progressive web apps to behave more like native apps. They wanted better OS integration and access to native APIs such as file system and context. We delivered on these features this year and will continue to work on making PWAs more capable. A new strategy we embraced this year is diving deep into specific use cases that represent critical user journeys on the web. Identity verification and payments authentication are two examples. We worked with developers who specialize in these flows and designed WebOTP and secure payment confirmation to make two-factor login and credit card step-up challenge more seamless and more secure. WebOTP is now shipping in M84 on Android after very positive feedback from the developer community. Secure payment confirmation is being tested in an A/B test on merchant websites powered by Stripe. The feedback from this pilot will help us improve the API before shipping. With unprecedented number of people working from home this year, WebRTC is a hero that enables hassle-free and browser-based video conferencing that everyone has come to rely on. In this area, we have shipped insertable streams that would allow applications to insert custom data processing, such as what's needed to build an end-to-end encryption. Pan and tilt support gives web developers more control of the camera so that they can build full-fledged video capturing experiences. Looking further ahead, teams working on WebXR continues to lay the foundation for a more immersive web. This year, we made progress shipping building blocks necessary for AR, and a few more projects are currently in the works that will build on top of these building blocks.
Yeah, and like any platform, we need to also help our developers create those great experiences we want to provide to users. One major effort on that front has been our work with open source frameworks and Next.js to improve the tools that developers use, and through that, improve our users' experiences. As part of that, we saw LCP improvements and JavaScript bundle reductions in the wild. We also shipped an image component that enables server-side image optimizations, font optimizations, as well as conformance plugins that look for performance and anti-patterns and call them out as part of the development process. A couple of mechanisms that give developers more control over what their documents and their third parties are doing are the document policy and permission policy mechanisms, or the artist formerly known as feature policy. Document policy essentially enables developers to disable harmful legacy features like synchronous XHR in order to ensure they and their third parties don't use them and drag down the page's performance as a result. And permission policy enables to ensure frames do or don't have access to powerful permission-based features like video autoplay or geolocation, and making sure that frames don't overstep their boundaries. Otherwise, another important piece of infrastructure is our origin trial infrastructure that enables us to experiment early with features before shipping them. But one downside of that traditionally has been that libraries weren't able to use that. Because they have no control over which origin is loading them, they couldn't have code that injects the right tokens and enables an origin trial for library users. That infrastructure got upgraded to support that use case, and now third-party origin trials are enabled, which enables us to experiment with many use cases we couldn't experiment with before. And for dev tools, we've seen a lot of improvements. CSS grid debugging support, as well as improved WebAssembly-related tooling, a shiny new issues tab that enables the browser to declutter the console and provide general guidance on issues found in pages in their own dedicated space. We have a few new panels, such as the media panel, the WebAuthn panel, and storage quota. And finally, the code base is being migrated to ES modules, TypeScript, and web components to make sure it stays modern and healthy.
And web platform test is an important piece of infrastructure for interoperability between browser engines. We continue to invest in it and have made various improvements this year to make it easier to author, run.
Looks like we lost audio, so we need to switch to a different meet.
Okay.
It's in the chat. Oh. Can you all hear me? Okay, so maybe we didn't lose audio.
All right, good. Technical glitch. It happens. This is, you now know we're live and now recorded. But yeah, going back to our platform test, I just mentioned we made a variety of different improvements this year to make it easier to write tests and to review them. In the ideal end state, we would like the web platform test to be the primary repository of end-to-end tests end-to-end tests that implementers will write. We're not there yet today, but more tests are being upstreamed every day. Special call out to the Galia team in conjunction with the ecosystem infra team and architecture team, Onion Soup team in Tokyo, is that they work together to help analyze over 350 CSS tests in March during the Chrome refactor freeze and upstream 250 to web platform tests. And thank you for the great work. And the investment is paying off. Between September 2019 and March 2020, Safari actually made significant progress, reducing Safari-only tests by more than half. And Chrome ecosystem infra team continue to triage Chrome-only failures and improve the triage process. Last but not the least, the MDN web developer needs assessments we started in collaboration with Mozilla has been a powerful instrument to help us understand developer needs. The first report was launched in 2019 and received almost 30,000 completed responses. We've made progress on some of the top missing features identified last year and will continue to invest in the others. The 2020 survey has just completed and we're in the process of analyzing the data. Doing this survey annually will keep us grounded and focused on building the features and tools that developers need the most.
And finally, we can't keep evolving the platform if we can get rid of Cruft. A few removal highlights from this year: App Cache, which is everyone's favorite villain, if I'm choosing my words carefully. Its support makes everything slower, so removing it is great. It's still supported as a reverse origin file to help lagging sites migrate to other offline solutions. Refer policy and the allow attributes for permission policy and document policy were cleaned up, and non-standard syntax was removed to prevent future compat issues. RTP data channels, a non-standard WebRTC extension was removed as well. Registered protocol handler was restricted to secure contexts. The discard element was discarded. And finally, at import rules are no longer supported in style sheet constructors. And speaking of removing Cruft, we made significant memory reductions in the past year by dropping unused JavaScript source strings and background tabs. We have a ton more work on the memory efficiency and safety front coming with projects like Partition Alloc Everywhere and Miracle Pointer. We also made great strides in reducing the use of legacy IPCs, as well as with projects like Onion Soup improving our layering and other code health improvements. And all in all, we had 157 intents to ship, 95 intents to prototype, 33 intents to experiment, and 18 removals. So amazing work, everyone. But enough about what we did. Let's talk about what we'll be doing this year. We have the lightning talks coming right up. And after that, we have various breakout sessions. The agenda is at the link above. But yeah, I'm sure you all know that already and know which sessions you'll be attending. So with that, let the BlinkOn festivities begin. Thank you.
Hi, so welcome to the lightning talk session. So the next slide, please. So I'm Haraken from Tokyo. Nice to meet you. Are you excited? So I cannot hear anything, but I'm assuming you are excited. Great. So this time, the lightning talks will be presented with a recorded video. So every time I am asking the speaker to insert one point where they can get a storm of applause from the audience. So however, that is not doable this time. So we edited the video and inserted handmade animations to the point where the speaker wants to get a storm of applause. So please enjoy the animation and give your applause over the screen. So before starting, I want to say a big thank you to all the speakers who created high quality videos. And I want to say a big thank you to Ashley and Casey who aggregated and edited all the videos. So thank you very much. All right, so let's get started. So enjoy the lightning talks.
Hello, I'm Gyuyoung Kim from Italia. It's an honor to be the first to present in the lightning talk. In my session, I would like to share the progress of converting legacy IPC to module. Okay, let me explain the legacy IPC conversion briefly first. This is one of the goals for the Onions 2.0 project. The IPC communications are still very spread widely, and the users have been blocking several high-impact projects, including backward cache, multiple BlinkOn isolate, and render document. So this module migration from the legacy IPC should be done as a prerequisite to further onion sweeping and refactoring. There were approximately 450 legacy IPC users in this January. To be more specific, content layer had about 264 IPC messages, and the others had 194 IPC messages. To help your understanding about module migration, this slide shows an example of how to convert the legacy IPC to module. This example is to convert view message on the update web preference IPC message to page broadcast module interface. To convert the IPC to module, the IPC message was moved to page broadcast interface first. Then, web preference parameter need to be converted to module type as well to pass it on the module message as parameters. After converting to the module message, the call sequence was changed like that. Thanks to this migration, we don't need to pass content renderer layer anymore. And we could remove unnecessary function related to this IPC message in the content renderer by making content browser communicate with Blink directly using module communication. Progress. Italia team has been working on this topic since at the beginning of this year in earnest. We have mainly been focusing on converting the legacy IPC in content for this year. In the content layer, we have been converting 217 IPC messages to module, and now 57 IPC messages are remaining in content. So 88% is done during this year. This is the graph and the table for the progress. Blue means the amount of IPC message in the content, and red shows the amount of others. As you can see, IPC used in the content layer have been decreased rapidly by Italia team effort during this year. That's it, and thank you for listening to my talk.
Hello, my name is Vadim Petrov. I am the head of the rendering team in the Yandex browser. I also respond for techno projects in Yandex browser department. And I would like to speak about one of these projects. Many SPA React-based websites generate new pages from data from server. They do work in big.js function. This function generates a lot of DOM nodes. Blink is single-threaded, so we can draw until function is done. Rendering has small job on main thread and most job on other threads. On the picture, we see a typical situation where JS code is slow and rendering is very fast. So we have an idea. JS function calls Blink for DOM operations, and execution goes to Blink. It is possible to call begin main frame and to do the job needed for the next frame. At this point, we have enough DOM nodes to draw something reasonable. Begin mainframe is very fast in comparison with JS, so the new frame is drawn quickly and CPU utilization becomes better. We have created a prototype and it worked perfect. So there is a quite simple algorithm. The first step is to detect execution of JS function which creates many DOM nodes. The second step is to wait until JS calls blink. The third step is to do begin mainframe on main thread. The first step is to continue our JS function. This is easy algorithm, isn't it? So we did the experiment and got 10% improvement of appearing of next frame and up to 20% for low-end Android devices. Thank you.
Hi, I'm Alex from Italia. Let me tell you about the progress that my team has done this year with Ozone abstraction layer. The Ozone layer lies below Aura. It wraps low-level input, graphics, interaction with the desktop environment, and so on. Ozone had been introduced to ease porting Chromium to new platforms, thus enabling it to be used in a variety of projects. It already has a few platforms, but none of them target desktop. Igalia started working on it a few years ago and initially implemented support for Wayland, which was the scope of our contract with the customer. To make it possible to switch the desktop Chrome to Ozone, in this year we have focused our effort on X11. Migrating the whole platform to Ozone took some time. One of key requirements was making the transition seamless and transparent for users, which means that we could not enable Ozone at compile time anymore. We had to make it available always, so it could be turned on and off at runtime. So we have moved and reshaped lots of code in many parts of Chromium to make it available in both legacy and Ozone modes. We have made tests working with Ozone enabled. Then we have silently enabled Ozone support in all Linux builds, and this went quite well and almost unnoticed. 1 year ago, on BlinkOn 11, we said that we planned to ship Ozone soon, like in 6 or 8 months. That took a bit longer than we expected, but we kept our promise. Ozone comes to desktop Chrome in M87. Every Linux user can now try it at home. However, so far there are some limitations. At this stage, Ozone is off by default. It can be enabled via the feature flag. If you want to try it, you will need to launch Chrome via the command line and give it 2 flags, one to enable Ozone and another one to choose the backend. We hope to start the Finch trial somewhere in the next year. Finally, here is the list of people who works on Ozone and helps with their views. Thank you for your attention.
Hi everyone, my name is Sreeja. I'm a software engineer at Google working in the back-forward cache team in London. I'm here to talk about closed tab cache. Let's dive in. Firstly, let us look at what tab restores look like without closed tab cache. The user accidentally closes the tab. They try to reopen the tab, and as we see, the contents are being reloaded back and it's not instant. The graph here shows how long the user takes to reopen the closed tabs. The data shows that 60% of the tab restores happen below 15 seconds. There will be a huge impact if we can instantaneously restore closed tabs and get a big UX win. Let's talk about closed tab cache now. Closed tab cache is a browser feature created with the purpose to make the reopening of closed tabs instant for very recently closed tabs. As we saw previously, the tab gets completely reloaded at any restore attempt. With closed tab cache, the page contents are kept in the cache for a short period to instantly unfreeze and restore it back. Now let's look at how it looks like with closed tab cache. In the same way, user accidentally closes the tab. They try to reopen the tab, and the tab, there it is, tab being restored instantly, no wait, no reload. Amazing user experience. Let's talk about eye-level overview of closed tab cache. User closes the tab or a multiple of them. We check that the tab meets its preconditions, like the feature is enabled and the tab restore service creates an historical tab. We store the tab entry in cache and start the eviction timer. In the meantime, user tries to reopen the closed tab. We unfreeze the contents and show the tab back to user. When the timer reaches, we edit the entry from cache. Let's see what integration with backforward cache. Backforward cache is a browser feature in contrary to support the page restores for backward navigation instead of tab restores. Closed tab cache reuses the architecture and is built on top of backforward cache freezing model. Considering high security and privacy standards, tabs which run JavaScript while being frozen are evicted from cache. Let's see what happens when the tab is playing audio or video. Tab is playing audio and video, and the user closes the tab. When the user tries to restore the tab back, the audio or video will be paused and restored in the same state when the user closes the tab. This feature is available behind a Chrome flag, and you can enable it by going to chrome://flag and enable closed tab cache feature. And let us know what you think. And thank you for this amazing team who made this possible. Thank you.
Hi everyone, I'm Daniel Libby from Microsoft, and today I'll be demoing new web APIs that developers can use to target dual screen and foldable device form factors. Broadly speaking, there are two types of foldable devices, dual screen devices and single screen devices that take advantage of flexible display technology. On these form factors, applications can reside on either side or be spanned across both display regions. A natural enhancement for websites is to logically split its content when in this new semantic window mode. This should just be another target for responsive web design, and we've proposed new APIs to support this pattern. Here we can see the default experience of web content when spanned on one of these devices, and one possible responsive layout designed to avoid the fold between the display regions and match content to the device. The proposed sets of web APIs exposes information about the logical segments of the viewport, both declaratively and via JavaScript. The CSS features allow for responsive design via media features and environment variables. And the JavaScript API allows for more complex scenarios to be achieved. Here's a way to achieve the previous example's layout. Here we can see the media feature scoping the modifications to this scenario where there's a single vertical oriented fold. The width of the inbox element is set to ensure that it expands to take up the entire first viewport segment. Some devices end up having pixels that are not displayed or masked underneath the fold, and this example also moves the email's content to avoid this gap. Here's a demo of the new web APIs in action in Chrome Canary using DevTools emulation. This is a simple example that demonstrates how to position these colored boxes based on the viewport segment geometry. When opening DevTools, you can see that there's an option to emulate the Surface Duo device. There's also a UI indicator when the experimental web platform flag is enabled. That flag, combined with emulating the spanning state on the device, allows for developers to test these APIs in builds today without needing a device. Here's the same page running in the Edge browser on a Surface Duo device. Again, if the feature flag is enabled, web developers can see how these APIs react and can be used on the device itself. So what's next? We recently had productive discussions in CSS working group at TPAC, and we'll be adding these APIs to relevant editors draft after some syntax updates. There's active work to land the integration with the Android support library to power these APIs in Chromium on these devices. After that, we hope to get more exposure and feedback from developers on their live sites by starting an origin trial. Please send any feedbacks or comments directly in email or via CSS working group GitHub issues. Thanks for listening.
Hi everyone, today I'm showing to you how you can build real-world apps using the foldable form factor. By foldable form factor, I mean these new categories of devices that are coming to the market. The one where you have a hinge that can move from 0 degrees to 360 degrees. On the left, I'm showing a dual screen device with a physical hinge to connect them. On the right, there is a device where the screen itself is foldable, and you've seen, for example, the Galaxy Z Fold 2 or this Lenovo X1 Fold. What's cool about these new devices is that they can be used in different ways. They can be used as a laptop, sometimes even as a monitor stand, sometimes as a tablet, or even as a book. What's the problem? Here's an example on a dual screen device with a physical hinge. Then as the browser window is spanned out across the two screens, the content becomes center, and then the physical hinge is on the way and cut the content. It's not that great. Here's another example on a news website. Doesn't look very good as well. So what can we do? So Intel, Microsoft, and Samsung have been partnering to bring new capabilities to the web platforms, and I'm highlighting them here. So what can you do to embrace the form factor? Using these new primitives, you can adapt it. So on the news website, I've decided to redesign my CSS grid to provide the 2-column views on these devices, and I align the 2 columns based on the hinge position. You can also provide a dedicated UI by improving the overall experience to the user. So I've decided to redesign this full screen scrolling view of pictures to a dual pane interface where I scroll on the left and show the details on the right. You can also embrace the form factor itself by leveraging the fact that it's being used as a mini laptop, for example. So that was a perfect match for the Battleship game where I'm using 2 different grids on each of the screen. And on the right, I'm showing a little game where I'm using the bottom part as the gamepad. Samsung also showcased a very cool idea where you can use the top screen as a viewfinder and the bottom as the previews and your screen controls. You can play with those demos on these URLs. Nothing is required. You don't need to have a special device. You can use the emulator that is available there. And of course, please send us feedbacks on the way on all those working groups that we are currently incubating these specifications. And then if you want, you can reach me on Twitter. Thank you for listening.
Hi, this is Jose Dapena from Igalia, and this is the 2020 edition of the Chrome and GCC Lightning Talk. Okay, so people are still using GCC. Because of vendor toolchains, vendor-specific toolchains or unsupported architecture, or maybe they are using components that are only working on GCC, or they are just not ready for moving to Clang. People may still also be using new Leaf STD C++, maybe because there are system C++ libraries not supporting LLV and Deep C++, or because of API incompatibility. As you know, you cannot mix Leaf STD C++ and Leaf C++ libraries. But Clang is the only officially supported toolchain in 2020. So GCC is not tested anymore in the official bots. And that leads to unexpected build breakage because of different interpretation of C++ standard, subtle differences between the Leaf C++ and Leaf standard C++ libraries, bugs in compilers or other components. So the status right now is maintain, hooray! Okay, so if you want to try the work, this is the meta bug for GCC work. In 2020, it's been 80 commits so far, and the main problems were related to templates and compatibilities and SIMD in 26. And about Leaf standard C++ metabug, it's been 33 commits so far this year, and the main problems are related to the difference in implicitly included headers in Leaf standard C++ that are less than Leaf C++, so you need to add more includes. There are also C++ copy and move requirements that are different in certain STL types. Okay, we have also this meta ledger for building this work on Yocto. So this meta ledger will use GCC and Leaf standard C++. It supports Raspberry Pi 4 on 32 and 64 architectures, Intel on 64, It's building Chromium development releases. It's based on Yocto Danful, that is stable release, and it supports nowadays only Ozone using X11 and Wayland backends. Credits to all the people helping this year: LG, Galia, Beardy, Gen2. And if you want to help, those are the links. Thank you.
Hey, I'm Alex from London, and I want to talk to you today about debugging Chromium. It's no secret that debugging is hard, and debugging a project as large and as complex as Chromium is very hard, and there are many reasons for that, starting from the scale and the nature of the project. However, I do believe that it's harder than it has to be, and while classical debugging approach like debug, logging, and fprintf scale poorly here, there is no reason why we can't have better tools for the job. Enter cron tracing. It's a performance analysis framework designed and built to record and analyze what the browser is doing, which is pretty much what debugging is about. As you can see on the screenshot, it gives you a full list of all processes and threads and all major things going on there, like tasks and IPC messages, as well as a lot of smaller stuff as well. So how you can use it now? For browser and layout tests, you can pass enable tracing flag to them. It will enable tracing recording for your test and will write a trace file containing the test name and the outcome of the test to the current directory. Then, by going to UI-perfected.dev and loading the trace, you can see what's actually happened in great detail and analyze and hopefully find the source of your problem and fix it. This approach works well if you're running multiple tests as well, with each test run being recorded in a separate trace file, and when combined with running the same test multiple times in parallel, this becomes a very powerful tool for getting actionable repros for flaky tests. Just a few tips and tricks to make this even more useful and practical. I recommend adding extended tracing enabled true to UGN args. It will enable a few additional trace events hidden behind compile flags, including detailed traces for module, including IPC message names, message payload, and parameters, and Blink bindings, which will allow you to see which APIs your page is calling. You can also use top-level flow category and associated flow events to see which tasks and messages are being posted and who posts them, giving you an insight into the overall task execution flow. So that's what you can do at the moment. But I believe there is a potential for much more here, and my ultimate dream is that every failed test on every build bot on any platform will give you an actionable trace, so you can see what's going on without the hassle of having to reproduce this failure on your local machine. For now, that's just a dream, but I'm hoping that I will be in a position to give a nice update for the next BlinkOn and perhaps a longer hands-on talk. So any form of help here is greatly appreciated. So if you're interested, here are a few links for you to check out and reach out. Would be happy to hear any comments and suggestions, and of course, any help here is appreciated. Thank you very much for your attention.
So, and I saw many people actually sending uploads over the screen and in the text chat. So thank you very much for doing this. So this is super encouraging for the speakers. So let's keep doing this in the following breakout sessions at BlinkOn. So your reactions make the speakers happy in this virtual configuration. So let's keep connected. All right, so we will have the second lightning talk session tomorrow morning. So see you again at 9:35 a.m. tomorrow. So thank you very much.
Good morning, afternoon, or evening, everyone. I'm Ashley Haman. In addition to flooding your inbox, I'm also working as an administrative business partner on the Chrome team. Before I pass the mic, I want to take a moment to highlight a couple of important announcements. First, if you take anything away from these announcements, it should be that the FAQ is available at bit.ly/blinkon-13-FAQ. This FAQ contains all the important information that you need to know about the schedule, Google Meet, Slack, and more. Speaking of which, Slack will play a much larger role in this event than in previous ones. So if you haven't already, please join the Chromium workspace on Slack and add the channels on this slide. as we're encouraging you to use Slack as your primary method of communication to ensure that everyone, even those who are unable to attend in real time, can join the conversation. The BlinkOn breakout room channels are intended for breakout room sessions, while the BlinkOn channel is intended for hallway conversations and main room discussions like this one. The BlinkOn channel has been quite lively throughout the session, which is awesome to see. But as I wrap up these announcements, please feel free to introduce yourself on it just to keep the ball rolling. An overview of all the sessions are available at bit.ly/blinkon-13-schedule, and more information about each one, including an abstract, is available by clicking on the Google Sheet links linked in row 2. In the schedule, you'll notice that there are 3 lightning talk sessions scheduled over the course of this event, with the first one having just taken place. Like Kentaro mentioned, we highly encourage you to attend the rest of these sessions at 9:35 a.m. Pacific tomorrow and the next day, as they're a great way for you to learn about several different projects, some of which will be further expanded upon in later sessions. You'll also notice that there are a couple of free time slots available in the schedule, so please feel free to sign up to host a breakout session during any of these slots. Given that all the sessions will be hosted via Google Meet, I've highlighted some best practices for using Google Meet on this slide, which I'll give you a moment to read through now. Okay, now that I've inevitably lost your attention, we're going to break for just over 30 minutes. Please feel free to use this time to engage in some hallway conversations before the next session, which will start at 11:30 a.m. Pacific. I hope to see everyone at the social event later today. Thanks so much.